Okay, so part 7 of our practice unit 2 video, and we're almost toward the end, toward the free response section. So let's talk about a basketball player has a 70% free throw percentage. Which plan could be used to simulate the number of free throws she will make in her next 5 free throw attempts? So we have to simulate 70%, and then we have to draw 5 times. So if I'm going to simulate 70%, I'm probably going to use 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And I'm going to use the first 3 numbers to represent missed, and maybe use the last set of numbers to represent made. Okay? And then I'm going to draw a number at random, 5 times to represent the 5 shots. Now, remember with the egg, it was without replacement. But here, if I start taking numbers out, okay, if I take 2 out, now all of a sudden the percentage is changed, right? I only have 2 missed shots and 7 made shots, and so the percentage actually changes as I start taking numbers out. So because the percentage changes as I take numbers out, I want to not ignore repeats. Okay, I want to not ignore repeats, because if I ignore repeats, if I start taking numbers out, I'm going to change the percentage. So what we want to do is not ignore the repeats. So let's see, for number 1, we have 0, 1 represent making the first shot, 2, 3 represent making the second shot, 0, 8, 9 represent making the 5th shot. Generate 5 random numbers, ignoring repeat. Okay, well, this doesn't preserve the percentage, so this is crap. Okay, let 0, 1, and 2 represent missing, 3 through 9 represent making. Generate 5 random numbers, and count how many numbers are in the 3 to 9 range. This is perfect. This is exactly how we set ours up. Alright, so 2 is good. Take 0 and 1 and 2 to represent missing, 3 through 9 to represent making. Generate 5 random numbers, ignoring repeats. Oh no. If we ignore the repeats, we change the percentage, and that's not good. So it can't be 3. Okay? So if we're only looking at 2, 29 is D. And that makes us happy. Okay? Now, 30. Let's scroll it up just a little bit so we can see a teeny bit better. Alright. Suppose the state decides to randomly test high school wrestlers for steroid use. There are 16 teams in the league. Each team has 20 wrestlers. State investigators plan to test 32 of these athletes by randomly choosing 2 wrestlers from each team. Is this a simple random sample? And the answer here is no. Okay? They're going to test 32 athletes, but they're going to choose 2 wrestlers from each team. Okay? So what you've done is you've stratified the samples, okay, by team. Okay, so that's the homogeneous trait, is that they're all on the same team, and then you're just picking 2. It can't be a cluster sample because there's no census. Okay? No, because not all possible groups of 32 wrestlers could have been in the sample. Right? I mean, it is possible to have 32 wrestlers from the same team be in a random sample. Not likely, but possible. Yes, because each wrestler is equally likely to be chosen. Remember, you're still equally likely to be chosen in a stratified sample. No, because a random sample of teams was not first chosen. Let's see, is this a simple random sample? No. Right, okay, so because the random sample, I'm sure, well, they're just taking all of them, but that's just because it's stratified. Yes, because all the random, no, okay. Each wrestler was equally likely to be chosen, but that's also true in the cluster and the systematic. Okay, so it's not this one. And it's not yes. It is a stratified sample, so it's not a simple random sample. So basically, it's no, and we were looking for a no because it's not a simple random sample, because not all possible groups of 32 wrestlers could have been in the sample, right? I couldn't have had a group that had 4 wrestlers from the same team in it. And so B is going to be the correct answer here. All right. And then let's see, 31. Which statement about bias is true? Okay. Okay. So what we want to do is we want to sort of define what bias is. And in the book, they say that bias generally over or under represents the parameter in the population. Okay, something that we're looking for. Maybe it underrepresents homeless people because they're hard to find, or we overrepresent people who like to answer polls or have time to answer polls, right? And so bias is very different from sampling variability. Remember, sample variability, or the book calls it error. I didn't like to call it error because then it seems to think that you made a mistake. But this is just due to random fluctuation. All right, so just because of random fluctuation, you get sample variability, right? And this is why the central limit theorem comes into place, because you're going to get p hats that are all over the place as you sample, right? So that's the variability, that's random fluctuation. So bias results from random variation and will always be present? No. That's sample variability, okay? It doesn't represent that, okay? Bias is an actual over or under representation because of the method that you use. Bias results from sampling method? Yes. Likely to produce samples that do not represent the population? Yes. This makes me happy, okay? So here's my check mark. Bias is usually to reduce when the sample size is larger. Well, if it's based on the sampling method, making the sample size larger probably actually exaggerates the bias. And so this is not going to be true either. So it's only answer 2, which is A. Okay? And so this makes us happy here. All right? Let's see if we can get 32 in under the 10 minutes that I'm kind of looking for to keep each of these videos at. If we wish to compare the average PSAT score of boys and girls taking AP Stats at the high school, which would be the best way to gather these data? Compare average PSATs. Oh, well, this is one of those times when we have all of the data, and it's probably going to be a small sample because it's just AP Statistics students. And so the best way of doing this is probably going to be to just take a census. Okay, so that one was short, so let's keep going on. A factory has 20 assembly lines producing a popular toy. To inspect a representative sample of 100 toys, quality control staff randomly selected 5 toys from each line output. Was this a simple random sample? So the answer is no, because not all combinations of toys could have been chosen, because it's just not a simple random sample. They stratified it. They stratified it by line, okay? It's not even a cluster sample because they've only selected 5 toys from each line, okay? So it has not. So we are only looking at the no's, okay? And so no, because toys do not come off the assembly line at random. Yeah, but you can still randomly select them, okay, off of the line. And so the answer here is going to be B. And then let's see if we can get 34 in. Which is true about sampling? An attempt to take a census will always result in less bias than sampling. Sampling error is usually reduced when the sample size is larger. That's definitely true. Sampling error is the result of random variations and is always present. Yes. And an attempt to take a census will always result in less bias than sampling. So let's think about this. They're actually attempting to take a census, And what could happen here is you could actually get a sample, okay, that was greater than 10% of the population. And when that happens, you can actually get more outliers that are not outweighed by the middle. And so you can really get some weird things that happen. But basically, we haven't met one of our 4 assumptions. And I think the big word here is because of the attempt. All right. If you had actually taken a census, then it's no longer a sample. And so if you're attempting to take a census to eliminate your bias, you could actually get more. And so 1 is not going to be true. So it's only going to be 2 and 3, and that's going to be B. And grammar is everything here in these situations. Okay? All right, that gets us to our 10 minutes. So we're going to start part 8 in the next video with the car dealership. That's supposed to be an 8. Okay?